Hi there, here we are again, another A-level maths video. We're looking at statistics year 1 at the moment in this video, and we're going to focus on section 2.5 of the textbook, which is all to do with coding. Now, before we get into the idea of what coding actually is, I'd like you to just have a quick starter question here on the screen. This is going to remind you about how to calculate means and particularly standard deviations. All right, let's see how we got on with this one. So I've done a bit of preliminary work here. I've added together all the items of data, and then here I've added together the squares of the items of data because I know I'm going to need to use that for my standard deviation calculation. So if you need a reminder about what that was, we square all of our numbers and then we add them all up. I've also just counted that there are 8 items of data here. So with all of this information, I should be able to work out what my mean and my standard deviation is. So the mean, of course, we've known about this for a while now, right? We add together all of our data, divide by how many there are. So in our notation, sum of the x's divided by n. So that's going to be 5,500 divided by 8. And you should get the answer there of 687.5. Okay, so what about the standard deviation? For quite a few of you, this is going to be a brand new idea. So you remember the formula for that? Well, it's the square root of this thing called the variance. And if you remember how we calculate the variance, it was the mean of the squares minus square of the mean. Okay, so mean of the squares means we square all our numbers, add them all up, divide by how many there are. So in that particular, or this particular instance here, we've got this quite a big number here. 3,960,000 is the sum of the squares. Divide by how many there are. Well, there are 8 items of data. And then subtract away the square of the mean. And we found the mean here, 687.5. Square that. Okay, put that in our calculator. And when we do that, we should get the answer 149.48, which I've rounded there to 2 decimal places. So hopefully you agree with that as the standard deviation. Okay, so hopefully that was a useful reminder about how we calculate standard deviation. Now, this artist, they didn't sell, unfortunately, he didn't sell any of his paintings, so he's decided to reduce the price of each one by £100. So information there on the screen. I want you to just see if you can work out what is the mean and the standard deviation of these new prices. Okay, so how did you tackle this one here? Now, you could have just worked it all out again from scratch, and if you did work it all out again from scratch, you should have got what I've done here on my paper. Now, I'm not going to go through every detail of this one like I did in the previous example, but you should have got the answer here for the mean of this new set of data is 587.5, and the standard deviation is 149.48. However, you could have possibly done it more simply, because what you could have done is you might have had the idea to think about relating it to the original values we found already. So let's bring those back up on this screen here. So if you notice here, the mean of the new set of values, the reduced set of values, is 100 less than the original mean. And if you think about it, that kind of makes sense, because if we're reducing all of the numbers by 100, then it makes sense that the mean, as a measure of location, a measure of how big the numbers are, is also going to reduce by 100. So perhaps you could have done it that way without working out all of this stuff over here. What about the standard deviation? Now, the standard deviation is a measure of spread, of course, and look, this hasn't changed. We've got exactly the same standard deviation. Now, why is that? Well, think about it. If you think about just reducing all of the numbers in our set of data, all of the values by the same amount, in this case 100, then are they going to get any more spread out? Are they going to get any closer together? No, they're going to stay exactly as spread out as they started. So therefore, the standard deviation, being a measure of spread, is not going to change. So this is a really, really useful and time-saving piece of information here. If we are just adding or subtracting the same value from every item of data in our set, then the mean is also going to be changed by that same value, increased or decreased, of course. And the standard deviation is not going to change. Okay, pause the video, think about that if you need to. Hopefully that makes sense to you if you think about it that way. All right, so back to this artist then. Unfortunately, he still doesn't sell any of his paintings, so he decides to change the price again. And this time he's going to go back to the original prices and then sell them at, or try to sell them at, half of their original prices. How do you think the mean price of the painting changes compared to the original now? And how do you think the standard deviation will change compared to the original? Have a think about that and restart the video once you've thought about it, please. So what are you thinking here? Let's talk about the mean first of all. So you might have come to the conclusion that the mean is also going to be divided by 2. And you'd be correct about that because, of course, when we divide all of our numbers in our set of data by 2, then they all move along our number line. They're all kind of half of what they were. So the mean is also going to be half of what it was. Standard deviation. Well, the standard deviation, of course, is a measure of spread. So do the numbers get more spread out or more close together when we divide them all by 2? The answer here is yes, they do. They get closer together, don't they? So our standard deviation is also going to be divided by 2. Now, if you want a bit of confirmation of that, I've done the calculations here. I've missed out some of the details here, but the original mean and standard deviation are up here. The new set of data here, I worked out the sum of all the values and the sum of the squares. And with those numbers, I worked out my new mean, which is this value here, which is exactly half of the original mean, exactly as we expected. The new standard deviation, I worked that out as well. And that standard deviation is also a half of the original standard deviation because those numbers have got closer together when we divided them by 2. So here we go then. So here's the result that we might want to make use of. When each item of data, when each item in a set of data is multiplied or divided by the same value, then the mean is also multiplied or divided by that same value, and the standard deviation too is multiplied or divided by that value. I'm hoping we're making sense of this so far, because this is a really important and useful idea in statistics when we're dealing with sets of data. And all this stuff we're doing is called coding. Okay, coding is what this section of the textbook is all about. And coding is really what we mean when we talk about changing the values in a set of data using the same rule for each value. So far we've subtracted 100 or we've divided by 2. And it's quite useful for us to be able to write these rules as formulas. So the example I put on the screen there, if we have the coding y equals x plus 20, well, x, we could use that to represent our original set of data. So therefore the y, the coded, the new set of data, would be where we take all of our x values and add 20 to them to form a new set of data, which we call y. And I'm hoping this is a simple enough idea that you can just have a go at a question straight away. So very small set of data I've put on the screen there, only 5 numbers in the set. There's a coding formula there. I'd like you to write down the values of this coded set of data, these new set of data which is related. Okay, let's have a look and see what you should have done. So the number 40 here, well, that's our first x value. We divide that by 10 to get the number 4. Okay, 50 divides by 10 to become 5. 70 divides by 10 to become 7. Another 70 divides by 10 to become another 7. And then the 100 divides by 10 to become a 10. So these are our y values in our coded set of data. Okay, so let's see if we can do a bit of coding now and see how it might work in practice here. I've put an example on the screen here, which I think we'll have a look at together. So we've got a set of values x. We don't know what the values are, but we're told that the mean and the standard deviation is 11 and 2 respectively there. We've been given a coding formula to code it into a new related set of data, and we've just been asked to find the mean and the standard deviation of those coded values. Okay, so we'll have a look at this one together so you can see how it works. So I've written down my mean and my standard deviation of my x values. I put a little subscript there underneath the sigma there to show that this is the standard deviation of the x values. That's quite a useful thing to do just so we can keep track of what's going on. Okay, so the coding formula was this formula here, y equals x plus 10 all divided by 3. So that means that the y values are going to be all the x values where we add 10 and divide by 3. We need to think about what each of those things do to the mean and the standard deviation one bit at a time. Let's consider the mean first. So the mean. So the mean of the coded values is going to be the same as the mean of the original values, but we need to think about how these things are going to affect it. Adding 10 to all the values, is that going to affect the mean? Yes, it is. So I need to add 10 to my mean. Dividing by 3, is that going to affect the mean? Yes, it is. So I need to divide by 3 there as well. So therefore, my new mean is going to equal the old mean plus 10 divided by 3. The old mean was 11, so we just end up with 11 plus 10 divided by 3, which I think, if we work out what that is, it just becomes 7. So my mean of my new set of data is going to be 7. See how that works? So that's hopefully quite straightforward. What about my standard deviation then? So my standard deviation of the y's. Well, we're going to start off by looking at the standard deviation of the x's, and then we're going to work out how each bit of the coding might affect that. Adding 10 to all of the numbers. Now, you remember adding did not affect any measures of spread. It didn't make the numbers more spread out or more close together. So therefore, I'm not going to adjust my standard deviation because of the adding 10. The dividing by 3, however, dividing did affect the standard deviation. It did affect how spread out the numbers were. So I am going to include that as part of my formula. Okay, does that make sense? You understand why I'm not including the 10, but I am including the 3. Okay, so the next thing I need to do here is just work out what the answer is. So the original standard deviation was 2, so therefore my new standard deviation is going to be 2 divided by 3, or just 2/3. I'll leave my answer like that. Okay, hopefully you see how that's working out. All right, here's a question for you to try, very similar to the one I've just done, so it's your turn to have a go at one now. Please pause the video and see if you can use this idea of coding to work out the mean and standard deviation of these coded set of data, please. So let's quickly just check the answers, see if you agree with this. So the new mean is going to be equaling 4 times the old mean minus 20, and that's because the mean is affected by both the multiplying factor and the subtracting thing here. So if we work out what that is, that becomes 4 times the old mean, 101.5, minus 20, which I think becomes 386. Okay, what about the new standard deviation? The new standard deviation, well, that's going to just be 4 times the old standard deviation, and that's it. Because, of course, the multiplying does affect the standard deviation, but the subtracting does not. So therefore, our new standard deviation is going to be 4 times the 22.5, which I think is 90. How are we doing with it so far? I hope we're following what's going on here. All right, one last type of question which I want to finish off with here. This is kind of trying to put it all together into a whole process here, and we'll have a look at this one as an example. We'll go through it together here. So let's see if we can actually work through this one together then. So you'll notice they've done a little bit of the work for us here. They've done the coding, and then they've told us the sum of the coded values and the sum of the squares of those coded values here, because that's going to help us calculate our mean and standard deviation. I've also noted the fact that we've got 6 items of data here, because that's going to help us too. All right, so let's work out first of all the mean of the coded data. Well, that's going to be the sum of the coded data divided by how many there are. In this particular case, the sum of the coded data is -5, divided by how many there are, 6. There is our mean of our coded data. Let's do the standard deviation. So the standard deviation of the coded data is going to be the square root of the mean of the squares of the coded data minus the square of the mean of the coded data. And let's work out what that is here. So the mean of the squares is going to be given by the sum of the squares, which is 39, divided by how many there are, which is 6, minus this mean, which we've worked out already, squared. And then if you work out what that becomes, I think we get not a very nice number as the answer, but it becomes 2.409, and the decimals continue like that. So there we go. There's our mean and our standard deviation of our coded data. So then the next thing we want to do now is work out the mean and the standard deviation of the original data, the x values. So we can now just do the decoding using the coding formula. So the coding formula, of course, was y equals x minus 237 all over 5. That was the coding formula that we used here. So let's work out the mean of the original data here. Now the mean is affected by both the subtracting and the dividing. So that must mean that the mean of our coded data, okay, I just need to bring this up so you can see it here, is going to equal the mean of the original data minus 237 over 5. The mean of the coded data, we worked that out just up here. That was minus 5 over 6. So let's see if we can get that here. So that must mean that the minus 5 over 6 equals x bar minus 237 over 5. And then I'll spare you the details. I'll just jump to the answer of that one. That means that our x bar, when you solve that equation or rearrange that equation, we end up with the answer here, 232.83, which I've rounded to 2 decimal places here. So there's the mean of the original set of data, which we had on the screen. What about the standard deviation? Well, the standard deviation, let's think about what's going on here. How does the coding affect the standard deviation? Well, the subtracting does not affect it, but the dividing by 5 does. So that must mean that the standard deviation of our coded data must be the standard deviation of the original data divided by 5, but not subtracting the 237. Okay, we worked out our standard deviation of the coded data up here. It was this number about 2.409. So I'll put that in here. So 2.409 is going to equal standard deviation of the original data divided by 5. And if you just multiply both sides by 5, we end up with the standard deviation of our original data, which happens to be 12.05. And again, I've rounded that to 2 decimal places. Okay, so quite a lot going on there. Please do, again, rewatch that and pause bits and think about it if you need to. But yeah, in a second, I'm going to ask you to have a go at one yourself. And here it is. This is the one for you to have a go at yourself. Very, very similar to the one I've just worked through. So please do make sure you study that and get the idea. And when you're ready, pause the video, give it a go, and we'll check the answers in a second. Okay, let's see if we just can compare answers here. I've written all of my answer out here already. So the first thing I did is I worked out the mean of the coded values. I got minus 2 over 5 here. And then the standard deviation of my coded values, I ended up with this number here, about 1.854. The number carries on. Okay, so that's my mean and standard deviation of my y values. And then I used those values to work out the mean of the x values here. So this was the coding. Undoing the coding here, we ended up with this value here of 3,420 for the mean of the x values. And then if I just move the paper up, you should be able to see the standard deviation. So my standard deviation of my x values here, just multiplying both sides of this by 50, I ended up with this number here. About 92.74 is the standard deviation of my x values. And there we are at the end of the video. So this is coding. Hopefully you get the idea about why it's useful and how we can make use of it by finding means and standard deviations more easily if we are looking at related sets of data which have been sort of transformed using some coding formula. That's it for this video, and indeed that's it for the end of this chapter. So please do consolidate this work by looking at the exercises in the textbook, but I will see you again next time for chapter 3.